right, so looking at this is going to be our test review for Unit 6. So in Unit 6, we dealt with different types of graphs and their inverses, and then looking at how that would affect different concepts of that graph. And we looked at being able to graph these not using our calculator, but being able to use those transformations and those direction tables. Okay, so the first ones that we're going to look at is our quadratics. So notice that these are both quadratics because they have an x squared. So the first thing I'm going to do is I'm going to graph this quadratic. So, one of the most important things is being able to figure out where you're going to start. So looking at this, I know my vertex is at -6, -2. So that's going to be kind of like my starting point when I'm looking at this graph. So I'm going to go over to -6 and then down 2. So there is my vertex. And then looking at this, when we started to look at our tables for a quadratic, I know if I go over -1, it gives me a +1. If I go over a +1, it still gives me a +1. So looking at this, those were kind of like looking at our parent functions right there. So from that vertex, I would go to the right one, up 1, left 1, up 1 as well. So that's going to be my parabola for that one. Okay, so if I look at the domain is left to right. And remember, if it is a regular parabola, that domain is going to be your negative to positive infinity. And then if I look at range is lowest to highest. So this does have a lowest point, and that lowest point, that y value, is over there at -2. And then it's going to continue to go up, so that would be your infinity. Okay, so looking at this, again, identify your vertex first, and then from there, for a quadratic, you're just going to go over 1, up 1, over 1, up 1, that direction as well. Okay, so now if we're finding the inverse of this, that means I need to switch my x and y values, and I'm going to do that on another sheet of paper. All right, so for the inverse, I'm going to switch my x and y. So that creates a new equation for me to get y by itself. Okay, so switch your x and y. So now here, I'm going to move that 2 over there, so that becomes x plus 2 equals the y plus 6 squared. So now that I have the squared by itself, this is where I can square root both sides. Because squaring a square root, those cancel out. So this leaves me with a positive negative, x plus 2. And on that side, I just have the y plus 6. Okay, I still have to continue to get y by itself. So now I need to move that 6 over there. So when I write it, I'm going to use that function notation, that inverse. So that inverse of the -1. And then that positive 6 becomes a -6 on the other side. So you can leave your equation like this if you want to. You can also switch it. So I could have plus minus the x plus 2 and then the -6 at the end. So realize both of these are the exact same equation. Normally when we're looking at these square root functions, you do have the -6 right here, because remember, that's going to be my vertex for this. Okay, so because I did not restrict the domain, I am graphing the entire thing with the plus and minus. So I am taking this parabola and I'm going to graph it, and I'm going to graph the inverse of it. That means that parabola is going to turn sideways like a C. So here, that is my vertex. So this vertex is at -2, -6. So I'm going to start at -2 and -6. Right there. Okay, and then I'm still going to go over 1, up 1 this direction, over 1, down 1. So here is that inverse function. Okay, so looking at that, we found the inverse, so we can go ahead and label it right here. We said it was the plus minus square root of x plus 2 minus 6. So that's your inverse function. And then looking at this, we graphed it, it's going sideways. Didn't give us a limitation on domain, so I did graph both the top and the bottom there. Okay, now the domain and range of this, remember, these two have a special connection. So if I have the original and I'm given the inverse, or I find the inverse, I know that the domain and ranges are just flipped. So I know this domain is going to be the same as the original range, and this range would be the same as the original domain. So they just switch. And if you look at it, my domain is over here, starts at -2, and it keeps going to the right. So that's -2 to infinity. And then the range, there isn't a lowest or a highest point, so that's that negative to positive infinity. Okay. So now we're going to do the same thing over here. So remember, I want to identify that vertex, kind of like where I'm starting my graph. Now for this one, I don't have parentheses, so I'm not adding or subtracting anything inside parentheses, so that means my vertex is starting at 0, and then that other value is 9. So 0, 9, which is going to be right there. Again, I'm using this same table, but here, remember, I have an a value. Whenever we have an a value, we multiply our y values by that a value. So for this table, when I'm graphing it, I'm going to go over 1 in each direction, but this time I'm going up 4. So I'm going to go over 1 here, and then 1, 2, 3, 4 is going to be about right there. And then this one is the exact opposite of that. So if I look at that, that graph did get skinnier because remember, that is a vertical stretch. So right here, that was a vertical stretch. It got skinnier. So if I look at the domain for that, again, it's that negative to positive infinity. And then the range, I do have a lowest point right there at 9. And then it continues to go up. So that would be the infinity. Okay? So now we're going to find the inverse of that. So that means I'm going to switch my x and y values. So I'm going to get my paper again and I'm going to write it. I'm going to switch my x and y values. So this is what I'm starting with. Now I need to get the y squared by itself. Notice here I don't have any parentheses. I'm moving that 9 over first, so that becomes a minus 9. And then I still have to move this 4 over because I can't square root it yet because I don't have that 4 out of the way. So the only thing being squared here is the y. So here I have to divide everything by 4. So when I divide by 4 here, realize that's going to be a 1. So that would be a 1/4 x minus 9/4, and that equals your y squared. So now the last step, now I have the squared by itself. So this is where I can square root both of them. Okay, so looking at this, I can square root that. That's going to give me a plus minus the square root of 1/4 x minus 9/4 equals y. Okay, so that would be my inverse. So I can go ahead and write that over here, my inverse notation. Okay, now also looking at this, realize, and we've talked about this, there's a greatest common factor here. Okay, so looking at that, there is a greatest common factor that I can take out. So that's what I'm going to do. So when I take out that 1/4, that's going to leave me with an x here. And then if I take out a 1/4 from a 9/4, that actually leaves me with a 9. So this is what I'm looking at when I'm going to be graphing it. So remember, whenever you're dealing with anything in this unit, when we're looking at our equations, if it has a greatest common factor, we want to take that greatest common factor out. Okay, so now looking at this, and when I'm looking at this one, I want to be able to find that vertex. So that vertex is going to be at 9, 0. So I'm going to go over 9 and then up 0. And then here, the 1/4, remember that is your horizontal stretch right here. So that means I'm going to be changing that horizontal stretch. So that would be the table. I'm going to write it over here. So looking at that, that means I would be multiplying these numbers right here by the 4. So remember, that's a horizontal stretch. Because that's your b value, remember we flip it. So that b value is 4. So I'm going to multiply these by 4. So that's going to become a -4 and +4. My y values are not changing. So if it's a horizontal stretch or shrink, that's your b value. That's where you're going to change the x values. Okay, so if I'm going to graph this one, so looking from here, remember you're going from this one, and this one's going to go off the graph, obviously. So, but from here, I would go over to the, like I'm going to try to graph it right there. Okay, so that's just sketching that graph. So obviously, again, you're going to go off of the graph. That's fine. So that just kind of tells you the direction that it's going. Okay, so looking at that, remember, we can flip-flop your domain and my range. So this domain now becomes this range, and that range now becomes this domain. So even without graphing it, if you do know your original one, you should be able to find the domain and range of your inverse even if you don't graph it. Okay, so that's another way that you can find that domain and range. So the first concept we started this unit with was if I give you a quadratic, that I can find the inverse and that I can graph both of them. Now also make sure if you find the inverse, is that inverse a function? So right here with both of these, because we did not restrict the domain, both of those are not going to be functions. So this is not a function, that inverse, and this one is not a function either. So because we didn't restrict the domain and said, only look at the positives, that means that's that full parabola that's turned sideways. So it does not pass that vertical line test. So neither one of those are going to be functions. Okay? Next section, no matter what type of equation you're given, you have to be able to find the inverse. And so we actually just did that in the first two. So we're going to do the same concept right here. You're going to have to take your x and y and switch those. So I'm going to do x equals the square root of y minus 1, and then I have that minus 5. So now that I have switched the x and y, now I'm going to solve for y. So I'm going to add 5 over to this side. And then once you're to this step, because I just have nothing but that square root left, I am going to square both sides. So this is going to leave me with x plus 5 squared equals y minus 1. And because we're leaving it in the graphing form, so we're just going to leave it in vertex form, I don't need to multiply that out. So if I want to finish getting y by itself, I'm going to move that 1 over there. So for this inverse, remember I'm going to write that inverse notation, I'm going to have the x plus 5 squared, and then I'm going to have a plus 1, because remember I moved that 1 over there, so that would be my inverse. Okay, same concept with the next one. So looking at the next one, switch your x and y. So now I got to start getting that y by itself. So I'm going to move the 3 over here, so I'm going to subtract 3. Now I have nothing but that square root of y left, so this is where I'm going to square both sides. So that function notation, the inverse, and I'm just going to have x minus 3 squared. So that would be my inverse. Okay, so both of these you were looking at just the square root. So remember, the opposite of a square root is to square something. Now if I look at the next ones, I have an x to the third. I'm still going to switch my x's and y's. So this is going to become x equals y to the third minus 5. So now looking at this, I'm going to get the 5 over there. So that's going to become x plus 5 equals y to the third. And then if I want to continue getting this inverse, remember the opposite of cubing something is to cube root it. So when I do that, that cancels out. So my inverse notation is going to be the cubed root of x plus 5. And that's how I would write the inverse. Okay. So a little bit different from the square root. Just understand, make sure you know the difference between the square root and the cubed root. Okay. Same concept here, but I have some things on the outside. Remember, you want to move everything away from that after you switch it. So I'm going to switch my x and y, and then I'm going to start moving everything over. So I want to move that 2 over there first. So that becomes x minus 2. And then I need to move the 5 over there. So if they're multiplying by 5, I am going to divide by 5. Okay, so I'm going to divide by 5 right there. So I am going to go ahead and divide both of them by 5. So that's going to be a 1/5 x minus 2/5 equals the y minus 3 cubed. So now that I have the cube by itself, this is where I can cube root both of those. Okay, so looking at this, that's going to leave me with the cubed root of 1/5 x minus 2/5 equals y minus 3. So the only thing I have to do to get that y by itself now is add 3 over there. So I ran out of room a little bit, but I'm going to have the cubed root of 1/5 x minus 2/5, and then that 3, when I bring it over, becomes a plus 3. So that would be your inverse notation. Okay, so finding the inverse, it doesn't matter what type of equation is given to you. The first concept, you always switch your x and y's first. So switch your x and y's, and then you're just solving for y. Don't forget, the opposite of square rooting something is to square it. The opposite of cubing something is to cube root it. The one exception for inverses, do not forget, if you are given any type of formula, do not switch your variables. So if you're given any type of formula in a word problem or just plain by itself, if they say it's a formula, you do not switch your variables. So like right here, I am not going to switch my c and my r. I'm going to leave it alone, and I'm just going to get r by itself. So if I want to get r by itself, I need to move the 2 pi over to the other side. They're multiplying by it, so I am going to divide by 2 pi on both sides. So that's going to give me r equals, and I'm just leaving it, c over 2 pi. And I'm done. That's all you have to do. Okay? If you're given a formula, do not switch your variables. All right, next one, compositions. To decide if something, when I give you something, are they're inverses of each other, you're just going to look at it and you have to use your composition. So remember, that's where you're going to find f of g of x first. If that equals x, then I have to find g of f of x. Okay, so this is where I'm taking this function and I am plugging it into the other function. So I am going to have 2 plus 4, and instead of this x, I am plugging in the square root of x minus 2 over 4. So all I did was take this function and plug it in for x right there. And then this is where you're going to simplify. So this is a big concept. Remember, squared and square root cancel out. So that's just going to leave me with the x minus 2 over 4 in the parentheses. And then right here, 4's will cancel out. So that leaves me with 2 on the outside plus, and then I have the x minus 2. And then here, these 2's cancels out. So I am left with x there. So that works for the first one. You don't forget, you have to go back and find g of f of x. So you do have to do both of those compositions. Okay, so the first one worked. So now I've got to take this function and plug it right in there for x. So I have a big square root, and instead of x, I'm putting 2 plus 4x squared. I still have a minus 2 over 4. So now I need to start simplifying it. So looking at this, if I start to simplify this, 2 and minus 2 are going to cancel out. So that's going to leave me with 4x squared over 4. Those 4's cancel out and leave me with the square root of x squared. Squareds cancel out. So that leaves me with x. So yes, these two would be inverses of each other. Okay, so you do have to do both compositions if that first one works. So if they simplify to give you nothing but x, they're going to be inverses of each other. All right, so if I look at the next one, I have a cubed root and a 5x to the third. It doesn't matter. We're still doing the same concept. So I'm still doing f of g of x. So I am taking this function and I am plugging it in right there for x. So I have the cubed root of 5x to the third over 5. Okay, so right here, if I start to simplify that, the 5's cancel out, and that leaves me with the cubed root of x to the third. Those cancel out, leaves me with x. So yes, that one works. So because that one works, I now need to do g of f of x. So now I am taking this function and plugging it in for that x. So I have 5, and then I'm going to do the cubed root of x over 5 cubed. Okay, so start simplifying. Remember, cube and cube root are going to cancel out. And then right here, those 5's cancel out, leave me with x. So yes, these are both inverses as well. So both of these gave you examples of two functions that were inverses of each other. This is the work you're going to have to show on your test, so make sure you understand how to find f of g of x and then g of f of x as well. All right, next section, writing equations. So it's going to tell you what type of equation. It's going to give you different points. So like right here, it says write the square root function that has a starting point of 1, 7. So this is my h and k, and it goes through 5, 3. That's my x and y. So looking at this square root function, remember this is what my equation should look like. So I'm going to plug in those 4 numbers and here, and I am solving for a. So I'm starting with y equals, so my y value is 3. I don't know my a, that's what I'm finding. And then it's x minus your h, so that would be 5 minus 1, and then plus that k value. So then we're going to simplify this. So right here, 5 minus 1 is 4. Make sure I take the square root of that. So this gives me 4. The square root of 4 is 2. So that's my equation I'm solving for a. So now I'm going to subtract 7 over there. So if I do 3 minus 7, that gives me negative 4. I divide by 2, so a is equal to negative 2. Make sure I don't stop here, okay? So I plugged in all these numbers to solve for a. Now I need to go back and write my equation. So you should always have a y equals equation right here. So my a value is negative 2, and then I have the square root of x minus my h value, which is 1, plus that k value. So that would be my equation. That's what you're looking for. So once you find your a value, make sure you go back and write your equation. Okay? Next one, same concept, except this one it says they want us to write a cubic function. So remember, that's going to be still an a, and I'm still going to have x minus h, but that's going to be cubed plus k. So realize all of these have an a, an h, and a k. None of that is changing. It just kind of depends on if it's a square root. You're going to have a square root right here. Cubic, you have an exponent of a 3. So your turning point is still your h and your k. This is your x and your y. So I'm doing the same thing I did up here. So I'm plugging these numbers in. So that's going to be 3 equals a, I don't know, I'm looking for. Your x is negative 4 minus your h value cubed, and then you have that plus k. So all I did was take all of those numbers and just plug them in. Okay, simplifying this, don't forget double negative turns to a positive. So this is negative 4 plus 2, which is negative 2. And then negative 2 to the third power gives me a negative 8. So I just simplified everything in parentheses and then raised it to the third power, and I got negative 8. So now regular two-step equation, so I'm going to add 1 over here, which gives me 4. And then divide by negative 8. So I actually get a negative 1/2 for my a value. Okay, again, make sure we go back and write our equation. So I should have y equals, my a value I just found was a negative 1/2, x minus my h, so that double negative turned to a positive, and then I have that minus 1. So this would be my cubic function. So make sure, again, that I go back and write that equation for that. Okay. All right, now we're going to get into some graphing. So all of this graphing, we did 2 of the graphing on the front. That was kind of what we started our lessons with that quadratic and just being able to find the inverse. So remember, we talked about the inverse of that quadratic is that sideways parabola. These were not functions because it doesn't pass that vertical line test unless we restricted the domain. So then what we started doing was we started saying, okay, if we're only looking at those positives, then we're going to look at these square roots, and it is going to give me something that's a function. So remember, if I'm giving you a square root, the table we're looking at, kind of like our direction table, is the 1, 4, 9 and 1, 2, 3. So this is our direction table that we're looking at whenever we're doing a square root. So basing everything off of this direction table, we still have to be able to find our starting point. Okay, so we're going to talk about the transformation, different vocabulary for this, but one of the most important things for that square root function, we have to find our starting point. So remember, it's in the same place as where the vertex would be. So here my starting point is going to be at 2, 0. So I am going to go ahead and graph, go over 2 and then up 0. So there's my starting point. And then remember, this is my direction table. So for this, because it has an a value, remember the a value, you multiply your y values by that. So for every a value, when I'm looking at creating my direction table, those x's are staying the same. So that's still going to stay 1, 4, 9. But here, these y values are going to be multiplied by 3. So that becomes 3, 6, and 9. So that's going to be my direction that I'm going to go for those ordered pairs. And all of these, I am starting from that starting point at 2, 0. So I am going to go over 1 and then up 3. I'm going to go over 4 and up 6. Okay, now the 9 and 9 is going to go off the graph. So if I go over 9, that's over there 1, and then 9 would be like up here. So that would be my graph. Okay, so for the square root function, it's always going to have a starting point, and then you're going to be going in one direction. The direction table always starts with this for square roots. For that a value, you multiply your y values by that. Okay, now looking at the next one, be careful here. Any type of function that we're given, we do need to make sure we take out a greatest common factor. So when I'm looking at this one, I can take out a 4, and that would leave me with x minus 3. And I can actually simplify this one further because if I look at the 4, the square root of 4 is a 2. Oops. So I'm going to have that 2 on the outside and then x minus 3 on the inside of that square root. Okay, so looking at this one, I'm going to look at this one. After we simplify it, now we can go ahead and identify my starting point. So when I'm looking at my starting point, that starting point would be at 3, 0. So I'm going over to 3, up 0. And then my direction table, again, my y or x values are not changing, but those y values, I now have a 2 on the outside for that a. So those y values, these original y values, are getting multiplied by 2. So this is becoming a 2, a 4, and a 6. Okay, so here I'm going to go over 1, up 2, over 4, up 4, and then over 9. So that would be like 2 off the graph, and then up 6. So that would be like over there. So that would be my graph. Okay, so I am going to go ahead and graph all these, and then we'll go back and look at the vocabulary. But again, looking at this one, be careful. Anytime you have a greatest common factor, you do need to go ahead and take that out. Okay, so looking at this next one, the last one right here for square roots, I have my starting point. I don't have a greatest common factor, so I'm going to go ahead and look at my starting point. So looking at that, that's a -6, -1, because remember, this is always x minus my h value. So because that's a plus, that means originally that was a -6 that they plugged in. So I'm going to go over -6 and then down to -1. So that's my starting point. And then here again, my a value is a 1/2. And I just realized we need to go back and look at that one. Nope, we're good. So looking at that, sorry, my a value is a 1/2. So I'm going to write my table over here because I don't have room. So looking at that 1/2, again, my x values are staying the same. Those y values are all getting multiplied by a 1/2. So these original y values, I'm going to multiply by a 1/2. So this becomes a 1/2. This becomes 1. And then that would become 3/2. So that gives me the direction table. So I had to multiply, because that's an a value, I had to multiply all those y values by a 1/2. So I'm going to go over 1 and then up a 1/2, which is just like in between there, over 4 and up 1, and then over 9, so that was 4, 7, 8, 9, and then up 3/2, which is 1 1/2. So it's okay to get fractions, and for some of these you will get fractions. It just means you have to go up a 1/2, so it might be in between lines, something like that. Okay, so looking at all of these square roots before we get to that vocabulary, we again have to find our starting point. That's one of the most important things you have to be able to identify. It's in the same spot as your vertex. So remember, this is my square root function. So that starting point is your h and your k. Okay, so looking at that, we have to be able to identify that starting point. And then remember, this is my basic table for square roots. So everything is going to be based off of this direction table for your square roots. Now, looking at the vocabulary, so you have to be able to identify domain and range of these graphs, and then whether it's a max or a minimum point, what the max or minimum point is, and then the transformations. Okay, so if I look at this first one, my domain, it starts over here at 2. So remember, your domain is your x value, starts at 2, and it's going to keep going to the right, so that would be the infinity. Range is lowest to highest, so this is the lowest point, and remember, I want the y value from that lowest point, so that would be at 0, and then it's going to keep going up, so that's infinity as well. And then this one, it's a minimum. It has a lowest point right here, and again, that lowest point is at 0. Now, for the max between 2 and 6, remember, this is giving you kind of a set interval. So these are your x values. So here's 2. So that's when x is 2. And then at 6 would be right here. So I'm asking you just between this interval, so just this part of the graph, what is the maximum point on this part of the graph? Remember, it's just like here. It's just your y value. So if I'm looking at the highest point, that would be right here. And that y value is 1, 2, 3, 4, 5, 6. Okay, so remember, these are your x values. It's giving you the interval to look between. And for the maximum, I just want that highest point. And again, it is just one number. It's just your y value. And then if I look for the transformation, what this transformation was, So remember, that's an a value. That's going to be a vertical stretch of 3. You have a vertical stretch by 3, and the number on the inside tells you that you moved right 2 units. So that would be my transformation. Okay, same thing on this one. Domain, I'm starting over here on the left, so I look at that x value is at 3, and then it keeps going to infinity. Range, lowest to highest, and again, that lowest point is at 0 for my y value. It keeps going up, so that's the infinity. Still has a minimum point, and that minimum point is at 0, because that's the lowest point, and that's the y value. So here I'm looking for the minimum between 3, which is right there, and 7, right here. So that minimum point, that lowest point is right there, and again, that y value is at 0. Okay, so that's all the vocabulary transformation from that parent function. So remember, we simplified this one. So this is what we want to base our transformation off of. So once you simplify it, that's what you want to look for your transformation. So because that is a 2 on the outside, that's your a value. So that would be a vertical stretch by 2. Okay, and then here, that 3 on the inside tells me that it moved to the right 3 units. And you can look at our graph and see when we graphed it that it went to the right 3 units right there. Okay, all right, and that last square root one that we did, so if I look at the domain, so the domain is all the way over here, so that's negative 1, 2, 3, 4, 5, 6. So that domain is starting at negative 6, and it's going to continue to go to the right, so that's the infinity. And then here, lowest for my range, my lowest value is at negative 1. And then it continues to go up, so that's the infinity. This is still a minimum right here, and that minimum value is at negative 1. Now I'm looking for the maximum value between negative 3, so 1, 2, 3, which is right here, and then positive 3. So there's your positive 3 right there. So realizing for that interval, that point was on our graph at positive 3. And remember, when we looked at it, that point was, it went up right here. So if I look at this one, that y value is at a half. Okay, so we had went up 3 halves from here. So remember, we went over 9, up 3 halves, and that ended up being that y value of 1/2 right there. So that would be the highest point for that interval. And then that transformation, so my a value is a fraction. So remember, that's going to be a vertical shrink by a half. And then on the inside, remember we said technically they plugged in a negative 6 right there. So that means it went to the left 6 units, and then it went down 1 unit. So for those square root functions, your direction table that you're paying attention to is this one right here. Okay? So looking at your square roots, remember the a, if there's an a value, you're going to multiply those y values by that. And then you also have to find that starting point. So that's the first thing you want to find, is that starting point to figure out where to start your graph. And then this is the direction table. So now if we look at the next 3, instead of a square root, here, okay. So here we have, these are cubic functions, and then this is a cube root. So for these two, we have a different direction table. Okay, so when I'm looking at a cubic function, my direction table is the -2, -1, 1, 2, and then -8, -1, 1, 8. So for these two right here, cubic function, this is my direction table that I'm looking at. Okay, I still want to find, instead of calling it our starting point, remember with these, it's called a turning point. So I am going to identify that turning point first. So that turning point would be at 1, 2. So that's where I'm going to start my graph, right there at 1, 2. Okay, and then these are my directions. I don't have to worry about changing anything because there is no a value here. So the a value is the same as the parent function, so I don't need to change this direction table at all. So that tells me I'm going to go over -2 and then down 8. So that would be right there. And I'm going to go over -1, down 1, +1, up 1, and then +2, up 8. So that's going to be up there. So when you're doing these cubic functions, remember, you should get those 3 points in the middle right there, and that's your turning point. So that one in the middle is the one that we find from our equation. That's my turning point. We should always have these 3 points in the middle that are pretty close to each other, and then you're going to have 2 that are kind of a little bit further apart. Okay, so if I look at that one for the transformation, same concept as what we just did with square roots. The number on the inside is left or right, so this would be right 1 unit. And then on the outside, this would be up 2 units. Okay, same thing for the next one. I'm going to find that turning point. So remember, because this is a plus 1, technically that was a negative 1, and I'm not adding or subtracting anything, so that would be 0. So I'm going to go over negative 1, 0 and put that point. Now, because this one has an a value, I do need to change those y's. Remember, if I have an a value, I change the y's. So my x's aren't changing at all. Those y values, I'm going to multiply everything by a negative 2. So that would become a positive 16, positive 2, and then a negative 2 and a negative 16. Obviously the 16s are not going to be able to fit on here, but I can graph the other ones. So looking at this, I would go over to negative 1, but then go up 2 instead of down, and then I would go over 1 here and down 2. Okay, I realize if I went over negative 2 and positive 16, that's going to be all the way up here somewhere. So you would be starting your graph here, and then it's going to go that way. So remember, because of this negative, that is a reflection over the x-axis. Okay, so the negative means it's a reflection over the x-axis, and then I take away the negative and look at the 2, and that is a vertical stretch of 2. And then the 1 on the inside tells me that it's going to the left 1 unit. Okay, so again, find your turning point, and then I had to change my table because of that a value. You take your a value and you multiply all of your y's by that a value, and that's where I got those new y values. Okay, and then that last one right here on this page is a cubed root. So now our table, our basic direction table is changing. So instead of this, remember, this is the inverse of a cubic function. So this one, I'm kind of running out of room, so I'm going to put my table here. So this table, it actually switches. So this is my direction table for a cubed root. Okay, I'm still going to find that turning point. So if I look at this, my turning point is at 0, 0, because I'm not adding or subtracting anything under the radical or on the outside. So I'm starting at 0, 0, but my a value is a negative 4. So again, just like with all the other ones, I'm taking these and multiplying it by negative 4. So when I go over negative 8, which is going to be over here, I'm going to multiply this by negative 4, so that's going to give me a positive 8. So then I'm going up positive 8. So that would be right there. Okay, and then here I have negative 1. So negative 1, but then I'm multiplying that by a negative 4, so that's going to be a positive 4. So that's right there. And then I have 1, so I'm going to go over 1. And then remember, I'm multiplying this by negative 4, so that's going to be down 4. And then that last one, I'm going to go over 8, should be right there, and then down 8. Right there. So those are pretty spread out. So when I look at this one, and I'm looking at being able to graph this one, so it's gonna, again, gonna look a little stretched out, but that would be my answer right there. Okay, so looking at this one, we do need to make sure that we can stretch that one out. That a value I had to multiply by negative 4, and that gives me that correct answer right there. Okay, all right, got some more. So still doing this. So right here, okay, so looking at this one, I have another cubed root. So both of these are cubed roots. So I'm going to rewrite that table over here just so we can see it on this page. Remember, this is the one that we're comparing everything to. This is that parent function, and this is like our direction table. Okay, so now looking at this one, I still want to find our starting point. So looking at this one, starting point is at 4, negative 5. So I'm going to go over 4 and then down 5. So that's my starting point. And then my a value didn't change at all, so I'm going to go ahead and just graph these. So I'm going over -8 and then down 2, over -1 down 1, +1 up 1, and then +8, and then up 2. Oops, +8 up 2. Okay, so here is that graph. Okay, and I did just realize we didn't do the transformation on the last one, so we'll go back to that here in a second. But looking at this one, transformation, my a didn't change at all. My 4 right here is going to tell me I'm going to go to the right 4 units, and then that's going to tell me I'm going to go down 5 units. Okay, the last one that we just did, I forgot to do the transformation right here. So looking at being able to write the transformation, remember that a value is negative, so that's going to be reflected over the x-axis. And then the 4 tells me that's a vertical stretch of 4. So make sure we can go back and do that. So I forgot that on the last example. Just did it on this example, and so we have one more with that. So looking at this last cube root, again, we have to find that turning point. So right here, I don't have anything underneath the radical, so that's going to start at 0, and then that would be -4. So I'm starting at 0 and going down 4. So that's kind of like my starting point. That's where the graph is going to start to turn and curve. So looking at this one now, my a value is 5. So that means all of these have to be multiplied by 5. So that becomes a -10. That becomes -5, +5, and +10. So from here, I'm going to go over -8 and down to -10. That's going to be off the graph. So here I would go over -1 and then down 5. So that would be right there. Up 1 and then, or so over 1, up 5. There. And then if I go over 8, this one I should be able to go up 10. That should be about right there. Okay, so again, these are pretty spread out, but remember it is that sideways graph, so it's going to look similar to that. Okay, a value, if you have an a value, you have to multiply your y values by that. Okay, so looking at this transformation, that is going to be a vertical stretch of 5. I don't have any left or right on the inside, but here that's going to tell me that it's going to go down 4 units. Okay, so for this graphing section, the most important part you need to know for the test are your basic direction tables. Okay, you need to know that for your cubed roots. So like right here, your cubed root, this is your basic direction table. Looking at what we did earlier for your cubic functions, this is your direction table. And then for your square roots, that is your direction table. So that's one of the most important things with the graphing on this test is you need to remember these tables. Okay, so now we've done all the graphing. So now we are switching to solving equations. So looking at this, we've written equations. Now we're going to solve equations. So you just solve them like a normal equation. You're trying to get the square root or that cubed root by itself. So looking at this, if you have anything on the outside, you need to move that first. So I'm going to take the +3 over to this side. So I'm going to add 3 over here to -27, which is going to give me a -24. I am going to then move that 4 over by dividing by 4. And that gives me a -6. So now that I have everything, I have that square root, I have everything moved over from that square root, this is where I can go ahead and square both sides. So that leaves me with a + 7 equals 36. Okay, now finishing that out, I would move the 7 over here by subtracting it. So I would get 29. Okay, the important part about these equations is making sure you go back and check your answers. You always have to make sure that it's works in the equation. So if I get a is 29, I need to go back and I need to plug that in. So right here, I'm going to type in 4 and then the square root of 29 + 7. Remember, I hit that over arrow to get out of the square root, and then I have minus 3. Does that actually equal negative 27? It does not. Okay, so looking at that, because that does not equal a negative 27, that tells me that this is not correct. That doesn't work, so that means this would be a no solution. Okay, so you can double check everything in your calculator, but you do have to go back and make sure that you check your answers right here. If it does not work when you plug it back in and it doesn't actually equal that, then that's a no solution because that answer does not work. Okay, so looking at the next one, I need to get, everything's already by itself, that square root's already by itself. So this is where I can square both sides. So that leaves me with c minus 1. And then here, remember, this is the FOIL method. This is where I have to do c minus 3 times itself. So you can do the FOIL method if you want to multiply it that way. Remember, I've also shown you the shortcut way. So I can multiply it out the shortcut way. So here, that would give me c squared. To get that middle term, I would do 2 times negative 3 times c is negative 6c. And then I would square the last one, and negative 3 squared is a positive 9. So either method, the shortcut way that I showed in class, or you can do the FOIL method. Some of you do the box method as well. So you can do the box method and multiply that out that way too. So either way, you're going to get the same thing, c squared minus 6c plus 9. So anytime you are left with a squared, I need to get everything to one side. So here, I need to move these over to this side by doing the opposite. So now I have 0. This right here is going to give me a negative 7c, and that gives me a 10. So now I need to solve this quadratic. So looking at this, we talked about you can solve it multiple ways. Most of these are going to be very easy to solve by factoring. So if I'm looking at this, I'm trying to find two things that multiply to give me 10 and add to give me negative 7. Okay, and that ends up being a negative 5 and a negative 2. So those end up working for there. And then you set each one of these equal to 0, so you know your answers are 5 and 2. Okay? Don't forget, we do have to check these, so we have to check both of them to make sure they work. But looking at this, anytime you're left with a squared, remember that's a quadratic, so you need to get everything to one side, and then you solve that. You can do this by factoring. If you want to do quadratic formula, you can do that as well. Okay, so now looking at this, plugging it back in to make sure it works. So if I plug in a 5 to my original equation, I got the square root of 5 minus 1, which is 2. So this side gives me 2. So if I plug in a 5 right here, that also gives me 2. So 5 is good. That one works. Okay, if I plug in a 2, the square root of 2 minus 1, that gives me 1. Whoops. Sorry, lights just went out. All right, so that's 2 minus 1. So that gives me 1 right here. And then if I plug in 2 right here, 2 minus 3 gives me a negative 1. So that does not work. So because that one is a 1 and that one's a negative 1, that means that 2 is not an answer. So your only answer would be the 5. So that's why it's important to go back and check your answers. So you have to plug your answers back into the original equation to make sure it's a true statement. Okay. Looking at the next one, you have a 1/2 exponent. That's the same thing as a square root. So I can rewrite this one as the square root of 6y plus 15 equals 9. So the 1/2 exponent is the same as the square root. So now I would just square both sides. So that gives me 6y plus 15 equals 81. Sorry, and then solve it from normal like here. So I'm going to subtract 15. So I'm going to have 81 minus 15 gives me 66. Divide by 6, and I get 11. Again, as always, double check your answer. So I'm going to plug 11 in. And you can use it as the square root or the 1/2 exponent. So even if I put the 1/2 exponent in, so I have 6 times 11 plus 15, and all of that is being raised. So remember, this is your exponent key right here. So that's being raised to the 1/2 exponent. So that gives me 9, which is what I'm supposed to get. So that would be my solution. So again, just make sure, double check, make sure your answers work. Okay, so those were all square roots. The last line is your cubed root. Same concept though. Okay, so we still need to get the cubed root by itself, which here it already is. So the only difference is to get rid of a cube root, you're going to cube both sides instead of square it. So that cancels, leaves me with the 5h minus 4. And then here, 2 cubed is going to give me 8. And then I finish solving like normal, so I'm going to add 4 to both sides. Gives me 12. And then if I divide by 5, that just gives me the fraction as 12/5. Okay, so again, always double check and make sure it works. So remember, I can do a cubed root, so if I hit the math key right here, the cubed root is number 4. So I would go down there and get the cubed root. So I have 5 times, I'm actually going to put this in parentheses because remember it's a fraction, and then minus 4. And that actually gives me 2, so that works. So that would be my solution. So even though it's a cubed root, you still have to plug it in to make sure it works as well. Okay, here I have a number on the outside, so remember, move that first. I want that cubed root or that square root by itself first, so I'm going to subtract 7 over there, which just gives me 1. And now that I have that cubed root by itself, now I can cube both sides. So that gives me 3x minus 5 equals 1. So regular two-step equation, I'm going to add 5 over there and then divide by 3. So I get x equals 2. Again, double check. So I'm going to have the cubed root. And if I plug in a 2 right here, 3 times 2 is 6. 6 minus 5 is 1. So I have the cubed root of 1 plus 7. It does give me 8. So that answer works. Okay. And the last equation, just like with your square root, if I have a 1/3, that's the same as the cube root. So right here, the 1/3 is the same as a cube root. I am going to go ahead and move that 18 over. So when I rewrite it, I'm going to have the cubed root of b plus 2. And if I subtract 18 over here, it gives me negative 2. So now I have that cubed root by itself. So I can cube both sides. So that leaves me with b plus 2 equals negative 8. And then subtract 2 to both sides. So that should give me a negative 10. And then last, make sure we double check it. So I have negative 10 plus 2, and that is raised to, so remember again, that's my exponent key, raised to the 1/3 power plus 18. Does that give me a 16? It does, so that means that would be my answer. Okay, so for solving equations, square roots and cubed roots, same concept, just get the radical by itself. And then you either square it to get rid of the square root or cube it to get rid of the cube root, and then you solve it like a normal equation. The biggest part about these is make sure you go back and check your answers. So even though you might get a number answer, you need to check it to make sure it actually works. If it doesn't work, then you could possibly have a no solution. All right, last one. You have a word problem. It's given you a function that represents the population of a city between the years 1970 and 2005. And it gives you this function right here. X represents the number of years. Using the function, in what year was the population of the particular city close to 281,000? So you have to know what this number is representing. And this is your population. So that's your P of X. That's where you're plugging it in. So when I plug this one in, you just have to make sure you're plugging it into the right part of your equation. So you are solving for X. I'm trying to find out what year, so I'm solving for X. So here, I'm going to move that 75,000 over first. So I'm going to divide it over there. So I have 281,000 divided by 75,000. That gives me about 3.75. Okay, so I divided that 75,000 over there. I got about 3.75. So now I have the cube root by itself. So now I'm going to cube both sides. So I'm going to have 3.75 to the 3rd power. That gives me about 52.73. And now to get that X by itself, I'm going to add the 1950 over there. So, 52.73 plus the 1950 gives me about the year 2002. Okay, so looking at this, just make sure if you're given a word problem that you can take any function, whatever number they're giving you, you have to know where to plug it into your equation. So here, this was population, so I had to plug it in for the P of X right there, and then I solved it like a normal equation. So I divided the 75,000 over, and then I can cube both sides and then add the 1950 over there to get my year. Okay, so a lot of graphing on this test. Again, for that graphing, make sure you understand those direction tables. Okay, make sure you understand the direction tables, make sure you can find your starting point or your turning point, and then also make sure that you can solve those equations.